In this lecture, I'll show you how to convert units using the factor label method. When I say convert a unit, what I mean is to take a measurement, like for example 6 feet, and to convert the measurement to a new unit without changing the true real value of the measurement itself. As an example, if I wanted to know how tall this person was in inches, I know that 1 foot is equal to 12 inches. So if I multiply 6 feet times 12 inches per foot, I get 72 inches. So these two measurements represent the same value, they're just written with different units. And because they're written with different units, they also have to be written with different numbers to make the two things equal. I can't just change the unit without also changing the number in some way, because 72 inches is not equal to 72 feet. So I need some way of knowing how to change a measurement from one unit to another unit without changing the true value of the measurement itself. The method that we use for converting units in this class is the factor label method. I've listed the 3 steps of the method here, so I'm going to take you through each step as I do 5 example problems to show you how it works. Example problem 1 says to convert 3,500 meters to kilometers. So I'll start with my original measurement that I want to change. Step number 1 says to multiply the number by a fraction with the unit that you want to get rid of in the part of the fraction that will cancel it out. So I want to get rid of meters, so I'm going to write a fraction and multiply it by my number. And because meters is in the numerator of my original number, if I put it in the denominator of my fraction, that will cancel it out. Step 2 says to write the new unit you would like to add in the opposite part of the fraction as the unit you want to get rid of. So I want kilometers in my final answer, so I'm going to put that in the numerator, which is the opposite part of the fraction as where I put meters. Step number 3 says to choose a number to put in the numerator and a number to put in the denominator so that the numerator and denominator are equal. I'll explain why we take this step in the final part of the video, but for now I'll just think about what two numbers would make these equal. I know that in every 1 kilometer there are 1,000 meters. The K actually stands for 1,000 or 10 to the third. So if I write 1 kilometer and 1,000 meters, those two numbers make the numerator and denominator equal to each other. So that's how you do the third step. I could have chosen other numbers. I could have chosen 2 kilometers over 2,000 meters or 0.001 kilometers over 1 meter. Any two numbers that make the numerator and denominator equal are okay. Finally, I just have to multiply this out, and when I multiply the number by the fraction, the meters cancel out because one's in the numerator and the other's in the denominator, and I'm left with 3,500 times 1 over 1,000 kilometers, which is equal to 3.5 kilometers. So 3,500 meters is equal to 3.5 kilometers, so I've converted the unit without changing the actual real value of the measurement. And that's how you use the factor label method. Example number 2 says to convert 50 kilometers per hour to meters per second. This will involve several steps. So we'll start with my original measurement. I've just added another sig fig there, just so my final answer can also have 3 sig figs. Step number 1 says to multiply the number by a fraction with the unit that you want to get rid of in the part of the fraction that will cancel it out. And I actually have 2 different units that I want to get rid of here. So I'm actually going to multiply by multiple fractions and just focus on one unit at a time. I'll start by focusing on kilometers. So because kilometers is in my numerator, I'll put it in my denominator. And I want meters in my answer, and I want that in the numerator, so I'll put that in the numerator. And now I just need to choose numbers that make those two things equal, and I know that there are 1,000 meters in every 1 kilometer. So I've successfully removed kilometers and added meters. But I still have hours in my denominator, and I need to convert that to seconds in the denominator. So I'll write a second fraction. And because hours is in my denominator and I want to cancel it out, I need to put it in the numerator of my new fraction. And I'll pretend that I don't know how many seconds are in an hour and just go from hours down to minutes just to reduce the time a little bit. And then I'll be able to get from minutes to seconds. I know that for every 1 hour there are 60 minutes, so that cancels out hours. And then I can write one more fraction where I go from minutes to seconds. And for every 1 minute there are 60 seconds. So that cancels out minutes, and now the only units that are remaining are meters in the numerator and seconds in the denominator, which is what I want. So 50 kilometers per hour is equal to 50 times 1,000 over 1 times 1 over 60 times 1 over 60 meters per second, which is equal to 13.9 meters per second. So if you have multiple units that you need to convert, you just focus on converting one unit at a time. Example number 3 says convert 3 years to seconds. So I start with 3 years. And I don't know how many seconds are in a year, but I can make the time smaller and smaller until I get to seconds, because I know how many days are in a year, so I'll put days in my numerator and years in my denominator. For every 1 year, there's 365 days. And I also know how many hours are in a day. For every 1 day, there are 24 hours. And I also know how many minutes are in an hour. And I know how many seconds are in a minute. So this is telling me that 3 years is equal to 3 times 365 over 1 times 24 over 1 times 60 over 1 times 60 over 1 seconds. And when I multiply that out, this is the answer that I get. I'm ignoring significant figures for this one. Example 4 says the volume of one bus is equal to 12 cars, 3 cars is equal to 1 truck, and 1,000 basketballs equals 1 truck. How many basketballs can be carried by 8 buses? So I'm going to take 8 buses and convert that to units of basketballs. So I can go from buses to cars because I have a connection there, and the problem says that for every 1 bus, we can fit 12 cars. And I can then go from cars to trucks because there's a connection there. For every 1 truck, there are 3 cars. And I can go from trucks to basketballs because I have an equivalency there as well. And when I multiply that out, I get 32,000 basketballs. Example number 5 says how many millimeters are in 2 megameters. I'm using this as an example of converting from one prefix to another prefix. So if you have 2 megameters, I'm first going to convert from megameters down to meters because I know the relationship there. For every 1 megameter, I know that the mega is standing for 10 to the 6th. So for every 1 megameter, there's 10 to the 6th meters. And then I can go from meters down to millimeters because I know that 1 millimeter is equal to 10 to the minus 3rd meters. So those cancel out. And when I multiply out those fractions, I get 2 times 10 to the 9th millimeters. We call each individual fraction here a conversion factor because we're using it to convert from one unit to another. The reason this method works is that each conversion factor is equal to 1 because the numerator equals the denominator, so multiplying by the conversion factor does not change the actual value of the number, but does change the unit. So no matter how many times you multiply by 1, you always get the same result. So that's why the factor label method works, and that's how you use it to convert from one unit to another.